Okay, so time for mill lab number 5. This is what we're going to do today. First off, I want to point out that this is dimension and metric. Yay, so everything over here in your program, except the RPM, has to also be in metric. Well, I'll explain more about that later. Why do we do metric? Because there are lots of metric parts out there, and sometimes it's just easier to do them in metric rather than convert them back to English. And what's interesting on a lot of metric prints, just a little fun tip here, is that an awful lot of them were once English, then they were converted to metric, and then you have to convert them back to English. Yeah, if you don't believe me, that's 6.35. You'll see that all over the place. I believe that's quarter of an inch. We're going to talk about the magic number 2 today, again in metric, which is 25.4. So let's take a look at what we got here. So we've got a square that's 150 millimeters by 150 millimeters by 50 millimeters thick. And in the center of that square is a round pocket. We can see that round pocket. It is 10 millimeters deep. And inside that pocket there are 12 holes. Okay, if you see where it says 12 holes equally spaced, and it says it's 35 millimeters depth from the top of the part. What it doesn't say here is what size these holes are. That's on me. The pocket diameter itself is 100 millimeters. Okay, so what we're going to do first off, we're just going to mill this pocket. We'll go ahead and mill the outside using cutter comp one more time. The reason we're going to do that is because one of the things that's most simple about doing a pocket, especially a circular pocket, is that a lot of times we're going to actually make our x0 and our y0 in the center of the part. All right, so yeah, and that's kind of what's going to go on there. So x0 and y0 is going to be in the center, and z0 is going to be on top of the part. I think I'm going to change things. I don't think we'll mill the outside on this one because we're going to have enough just converting to metric and doing the pocket. In the next video, which will be mill lab 5A, I will drill these holes. We will center drill, countersink these holes. Okay? That's what we'll do in the next lab. So right now we're going to start off again. Let me point that out again. X0, Y0 is going to be in the center of the part. Z, of course, is going to be on the top of the part. And we do have to convert some things to metric. So let's take a look at our startup block here. We've got that all going, lines N10 through N50. Remember, the program name has to start with a capital O, and of course we always have to have a percent sign up here. That's very important. If you don't have it, the control won't even read it. You'll go, I don't know what the heck this is. It won't even load it. Okay, so I've got my name here, which is what you should have there, lab number 5. Our safety line is pretty much standard except for one thing. Since this is metric, remember G00 puts it in rapid. G17 says we're going to do arcs in the XY plane. We are. G21. Now normally we would have a G20 there. Okay, excuse me. Boy, we're starting off on a good note here. Okay, so normally we'd have a G20 there, which means we're working in inches, but now we're going to have a G21 because we're working in metric. Control S. Okay, G80 means we're going to cancel any active can cycles. You may have been getting a strange error if you've been using NC Viewer about this maybe not being supported, or on some controls they don't like the G80 in the same line as some other things. You can always put it another line and let it stand alone, but it needs to be up there. I guarantee you this line will work in a Haas machine just fine, and 95% of Fanuc controls. Now we talk a little bit about the history of pocket milling real quick here. There was a time, especially circles, we could only do 90 degrees arcs at once. That's it. We could do less than 90. We could do 10 degrees of an arc or 20 degrees of an arc or what have you. But the most we could ever do was 90. So we could mill from there to there, then we had to mill from there to there, then we had to mill from there to there and there to there and so forth. Let me go over here and I'll get the pointer going. So we could only do 90 degrees at a time. That is long since gone. We can do a full 360 degree circle, and that's what we're going to do today. Now, real quick, we're going to start in the center, and we're going to do a circle. Then we're going to move up and do another circle because we're going to clear this pocket out. Okay, We are going to leave, let's say we're going to leave 15 thousandths on the bottom of the pocket for a finished pass in Z, and we're going to leave 15 thousandths on all of these surfaces here for a finished pass in both X and Y. And we get that all done. So we're going to make basically two passes. We are going to use cutter comp in this, of course, and I'm going to show you all how to do that here right now. So let's click here, turn that off. Let's see what else we got going on. Of course, we've activated our work offsets. That's always going to be there. We could actually do some different things with this on this part, but we're going to leave the G54 alone. It's still a little more, we'll get to the more advanced places where we use multiple work offsets on the same part. I'll tell you more about that later. So we've done our tool change. We're going to go to Tool 01, MO6. Since we are working in metric, we're going to be using a 3/4 inch diameter end mill. So if you put in 0.75 and we multiply it times the magic number, which is 25.4. Remember, when you're going from English to metric, you multiply times 25.4. When you're going from metric to English, you divide. Okay, so we just hit that, and this should tell me right here, there, that is the metric equivalency of 3/4 of an inch, which 3/4 of an inch is 750 thousandths. So 1905, I've got that already up here. So we're going to use a 19.05 end mill, and it's going to be a 2-flute end mill that's center cutting. Now I'm going to tell a little bit about center cutting end mills. Center cutting end mills are end mills that basically they will cut all, they have blades. If you look at the end of them, they go all the way across. There is no hole in them. A lot of end mills, if you look, you'll see a hole for like a center or something like that to do the grind work. Center cutting end mills basically can be plunged directly into the work like a drill. And actually, end mills, we use them a lot of times when we want extremely accurate holes, or holes that are on position, or maybe we put a hole slightly off position and we center drilled it and we had to move it. The best way to move it would be just to plunge with a 2-flute center cutting end mill. They do make 3 flutes and 6. They make all different number of flutes in center cutting configurations, but 95% of the time, I have to say that because every now and then there'll be a 2-flute that's a non-center cutting, but it will be. We want that because we're going to plunge directly into the work. All right, so let's go ahead and calculate our RPM up. Now it's easiest just to calculate your RPM up just by doing it. Now we're going to use a cutting speed of 100. It's up there, 100 times, I'll go ahead and do it, 3.82 equals this, and we're going to divide it by 0.75, and we end up with 509 for our RPM. Now remember, I'm just going to round it to 500. I don't need 509. 500 will be just fine. Alright, so we'll clear that out right there. So we've got that up here. We've got our spindle going clockwise. S500, remember there's no such thing as an MO3 without an S word behind it. You'll get an error. Spindle on clockwise at 500 RPM. RPM is the only thing that does not have to be converted in metrics because revolutions per minute are revolutions per minute. It doesn't have anything to do with metric or English. Okay. Next thing we've done in line 50, we've done our standard stuff here. We've gone ahead and activated our tool length offset, and rather than bring it down to 1, because if I had like a Z1 here, okay, that would bring it down to 1 millimeter. It would wrap it to within 1 millimeter of the top of the part. 1 millimeter is 25 thousandths. That's a little less than the thickness of a dime. You want to scare your operators or scare yourself? Go ahead and do that. 25.4, that's 1 inch. If you don't believe me, really, do I have to do that, times 25.4? I'll do it anyway. There you go. See? Yeah. So let's do it again, right? 1 times 25.4. We're going to do a lot of this. Equals 25.4. Right. So 25.4 is 1 inch. All right, so 25.4 millimeters. H01, remember that always has to coincide with the T number. It has to match that. So we got our tool length offset on. Okay, so what's the next thing? I'm going to go ahead and skip a line here just for clarity purposes. Remember, the machine doesn't give a damn about open lines. It doesn't. And we're going to do we're going to do this as efficient as possible. So the first thing I'm going to do, I've got rapiding, it's in rapid, the G00 is modal. I'm going to go then let's go to the center of the part, X0 period space, Y0 period space, and Z. Now if you put Z.1 here, you just screwed up. You went in, you rapided to within 100,000th of a millimeter. That's not going to work. So we need to convert 100 thousandths, right, to metric. So 0.1 times 25.4 equals 2.54. Shouldn't have been such a surprise. That has to be changed. I'll be looking for that. Promise you. Control S if you haven't done that. New line, N70. Okay, whoops. Really? I thought I had caps lock on. Okay, N70. So I went to X0, Y0. I have to change these because I didn't have a caps lock on. Now, by the way, Predator Editor will actually convert everything to caps for you too. Control S. I got to get my Z to as capital. Oh yeah, I had to shut this stupid computer off. That's right. So I forgot to reset my caps lock on. Okay, now that I've got to X0, Y0, and Z is coming down there. Probably a good idea to turn the coolant on too. So let's go M8. You don't have to put the 0 in there. Okay, on most controls. I'm going to tell you right now, I was fooling around with a different piece of software here called Chemotics. And this is like for hobbyists. It's a CNC software for hobbyists. And you can actually buy these a little CNC control with little stepping motors. I think I'm going to buy one. They're not that expensive, around 500, 600 bucks, and make me a little CNC machine, maybe a wood route or something. That control is very, very unsophisticated. Matter of fact, it doesn't even recognize modal commands. I've been fooling around with it knowing, oh my gosh, I got to put the F word in every single G code that I put up there. If it's a G1, G2, or G3, it's got to be followed by an F word or it errors out. So just going to show you again, there are differences between controls. All right, enough of that. Let's get back to here. So what we want, G1, because we're going to plunge. That's the first thing we're going to do. Let's get the calculator out of the way here. We'll put her down here in place. That's good. Okay, so I'm going to plunge right here in the center. Now, so that means the z-axis, G1, that's linear interpretation, z minus, how far do we want to go? We don't want to go down 10. I said 15 thousandths, didn't I? I sure did. I said 15 thousandths. So we have to convert 15 thousandths to metric and subtract that from 10 millimeters. Yeah. So 0.015 times 25.4. Look, I've done this so much on some calculators that the 2, the 5, and the 4 are wore off the buttons. Okay, so that's 381. I'll hit memory store. We're going to use this a lot. So get used to using this memory store button. We're going to use this a lot. It will save you a lot of time. If you don't do it, you can do it the other way, but it'll certainly make you a lot more efficient programmer. So 10 minus and memory recall equals, this is my z depth, so I'm going to go down minus 9. Well, what was that? I should have copied it. Here we go, copy. And see, this will save you a lot of time too. There. Now, 3 places in metric is a small amount. Control S if you haven't done it. That's a thousandth of a millimeter. We call that a micron. What is a thousandth of a millimeter in English? Well, let's take a look real quick here to show you just how small amount that actually is. 0.001 divided by 25.4. You probably already can see this coming. Oh geez, oh Pete's, it was so small it gave it to me in scientific notation. To the negative 39 millionths of an inch. Okay, that's 1 micron. 1,000th, that's a micron. 39 millionth of an inch. All right. So you don't have to carry these things to 3 places, all right? So don't. All right, now for every G01 there's an F, so we got to calculate up our feed. I believe I said 2.5 thousandths. Yes, I did. I said 2.5 thousandths feed per tooth. We've got 2 flutes, so we got 2 teeth. So let's calculate that up real quick again. Pop. So we got 0.002, 2.5 times 2, that equals 5. And then of course multiply that times our RPM. And we end up with 2.5 inches per minute. Now, if you put 2.5 up there, you're going to move 2.5 millimeters per inch. Okay? You got that? That is not going to work. So don't put 2.5 there. We have to take 2.5 and convert it to what? Metric. And we just do that by multiplying. So times 25.4, boom, 63.5. Sounds like a lot, but it's not. Remember, that's millimeters per minute. Okay, and you do have to express your feeds in millimeters per minute. The only thing that you don't have to express in millimeters on a metric print is the RPMs. Okay, got it. Very good. All right, let's go ahead and do this one. If you haven't hit Control S, do that again. All right, so what do I want to do now? Well, I want to activate my cutter comp. And remember, we have to make cutter comp. We have to make a move that's greater than the radius of of the cutter. And I'm going to make it 50 thousandths greater. So I'm going to come up with a number here and show you how I come up with it. So we're using 19.05. So this one, since that's already converted, I'm just going to go ahead and here hit clear. All right, so I got 19.05 divided by 2 equals that. That's not quite enough. Now I want to add 50 thousandths to it. So I'm going to hit that memory store again, and I'm going to put 0.05 times 25.4 equals that much. And then I'm going to go plus memory recall equals, okay. Now let's see, because right there I've got that. Now that doesn't quite look right. Okay, I'm going to try that again because just again it won't hurt. So let's clear the whole thing out. Let's go 19.05 divided by 2 equals that. That's half. I want to add 50 thousandths to it, so I'm going to store that again in memory store. So I'm going to put in 0.05, okay, and multiply that times 25.4. I got 1.27, okay, and plus memory recall equals, okay, I was right, it's 10.97. That's what I want, 10.79. We round to 10.8, that'll be fine. Okay, so 10.8. And I would write that down. Actually, I am going to store that in my memory because that is how much I'm going to have to add. Okay, no, but I'd write it down. 10.8 would be fine. So let's clear that out. Boom. All right, so let's activate our cutter off length offset. So again, we want to make sure that we get a G01 there. Now, which side is this cutter on? Well, give me a second here. I want to get my little this going. I'm not going to do anything with it, but remember this is like our end mill. So we're going to milling in a counterclockwise direction. Why are we going to mill counterclockwise? Because that's climb milling, and remember we always want to climb mill. Better surface finish, better tool life, better part geometry, just better lots of things. And CNC machines like to climb mill. They have anti-backlash take-up circuits or backlash take-up circuits in there, and that compensate for backlash. Backlash is the play between the feed screw, the lead screw, and the feed nut, and there is always going to be some backlash. This takes care of it. So we're going to go that way. So if you put this right here, which side is this going to be on? Because remember, this is a pocket, so I'm going to be milling on the inside. Well, that looks like that I'm on the left side of it. If you put it over here, it looks like it's on the right, but remember, you have to pretend you're riding the end mill. So you come all the way around and like this, and you're on a lawnmower and you're riding a circle. You're still to the left of that line, but this time you're looking this way. That's confusing because I'll put it here. So it is going to be a G41. You're just going to have to trust me on that. It is a G41. Okay, G41. And remember, now we want to make a move. So that move is going to be, well, we want to move at least half the diameter. I had 10.8, so I'm going to make a Y move. Now, you could do this in X and move over this way, you know. I just always was taught this way, to go this way because that's 12, 9, 6, and 3. So I'll go up to 12, so Y. So Y, what was it? 10.8. 10.8. And now this Camatics, again, like I said, it does. I would have to put in this point right here, I have to carry that F. I don't want to put it in there because I know I don't need it, and in very expensive machine and regular CNC stuff I don't need it, so I'm not going to do it. And what do I need to do there? Well, I do need a D number. Now, I've been trying to figure out where to put that D number. I'm going to put D01 there. Put the D01, don't put D1, just put D01. So that should effectively activate our cutter diameter compensation. So let's make sure we got our coolant on here. We're in position. We fed down, leaving 15,000 stock on the bottom. Then we fed up in Y to Y 10.8, and we activated D01. Like I said, on some controls, you may have to carry that F over here. I don't think you do. All right, but you know what? I know you don't on a Haas, but I'm gonna put it in there anyway, just so that we're all happy. Okay, very good. So N90. All right, now what are we gonna do? How do we mill a complete circle? As I just got through saying a little bit ago that you can only do 90 degrees at a time back in the 80s. Well, we're not back in the 80s. There's lots of times I wish we weren't back in the 80s. Eddie Van Halen died yesterday. So that's where I'm at. Eddie Van Halen died yesterday. What a terrible day. Anyway, uh, let's get past that. Sorry, getting a little nostalgic. So what we want to do is, first off, since we're going clockwise, counterclockwise, right? We're going counterclockwise. That's a G what? I'm just going to wait till you tell me. I know I would do that in class, but I'm not in class. Control S. This is a G3. Now, what makes this do this? You think, oh my gosh, I want to put in all kinds of strange stuff here. End, start point. It's actually very easy. You're going to go use a J. That's right, the letter J. Now, there was a time when we used I and J moves on all our arcs, and that time is pretty much gone, at least for manual programming. If you go into a CAM system, you'll see it spit out I and J moves all over the place. These were just ways that we used to have to cut arcs. We don't have to do that, but we still have to use it to do this. It's going to be a J and it's going to be a minus. Why is it going to be minus? That makes it go all the way around. So you can call that the J minus number. Now, right now, that's got to be the radius of what you want to cut. That is going to be whatever the radius is. In this case, we moved up to Y 10.8. That is going to make us a pocket that's twice that big. I can calculate that up. I believe it's 21.6, but I'm probably no good with that. So let's do 10.8. I was right. Okay, just doubting myself here. So with the 21.6, that's what this right here, since I moved up, that's the radius that this is going to cut. So guess what? All you have to do is do the same here. I know that seems unbelievably simple to make. That right there will cut a full circle. And it's going to cut a 21.6 diameter, 21.6 millimeter diameter circle. Okay? It will. It's going to cut it at 63.5 millimeters per minute. And again, we're going 9.61. Now that is not too deep for a 3/4 inch end mill. All right? It's not. That's fine. We can do 10 millimeters real easy. All right, that's 3/8. It shouldn't have a problem. A lot of people would say, well, maybe you should leave a little more stock in 15 thousandths. All right, that's just something you have to do. If this was harder material, and since I'm using cutting speed of 100, I'm assuming this is a pretty relatively soft stuff. If I was using harder material, I might make this in 2 passes, 3 passes, you know, half and like 5, and then 9.61, and then finally 10. So 3 passes. But this is it's relatively soft stuff based on the cutting speed. So I'm going to just go ahead and say that's going to be fine. Now we'll cut our circle right there. That's all you need. A G3 and a J minus. Now if you put that minus there, if you do not put that minus there, it won't work. Okay? And there'll be a lot of you will do that. Go, why won't it work? Well, you probably didn't put the minus in there. Control S if you haven't done that. Okay, new line. N100. All right, so I'm going to go back to G1. All right? I don't need the G41 anymore because we're already active. Now, the question is, how much? We got to clear this whole pocket out. So how much do we move the cutter up each time and make a new circle? Because that's what we're going to do. We're going to move up, cut a circle, move up, cut a circle, move up, cut a circle, until we get the whole thing done. Well, generally, that's dependent upon a lot of things. It's dependent on the hardness of the material, the depth of cut, the diameter of the end mill. There's just so many variables in that decision that it's something that you just kind of learn. I'm sure I could find some formulas in your CNC handbook that would tell you exactly what a perfect step over percentage would be. Percentage of the diameter of the end mill. I am going to go, let's say we'll go half of it. Yeah, that'll ought to work. So we're going to go half of the diameter. So half of that diameter, I'm going to get that right in here right now. So I got 19.05. It's so much easier for me to do this. Divided by 2 equals that. That's half the diameter. I'm going to store that. I'm going to clear the memory just in case and go memory store. That number, that's what you need to do. Get that number in this calculator because that's going to save you a lot of time. Okay? Really is. So right now I want to go G01 and I'm going to go, let me bring that back up here because this is something I'll show you again. You want to copy. We'll get this going. Copy it. Put my Y there because we're going to always make a Y move first. And then we're going to paste. Okay. We shouldn't have to put that 63.5 there. Like I said, this Camonics, it definitely wants a feed at every single one of these G codes, which is stupidity. Okay, I'm not going to use it. I was going to introduce it to you, but the truth there is it's just too gimpy. It doesn't work good. So let's just leave the feed alone. We're going to say it's going to work. Okay, so what do we want to do then? We're going to want to cut another circle. So that's a G3. Now, here's something you can do. All right. I'm not going to do it right yet, but we could copy and paste this right here and just change this number. I could copy and paste this whole thing and just change the number. And I don't care how you do that. That's up to you. For me, I have to teach, so I have to type in the G3, and then I'm going to go Y. Now, is that right? No, it's not. It's a J minus. Remember? That's right. This is what makes it cut that. So, and how much do I want it to be? Well, now I went up 9.52. Is that right? Hopefully you said no. It's not. Let me show you why it's not. Because I was already at 10.8. I just moved down and cut a circle smaller than the one I already cut. So I didn't cut anything. All right, that's what I was getting ready to do. That number, let me show you what we want to do. Okay, since I've got this, let's clear this all out here. I've got that. I'm going to put in 10.8 because that's where we stopped. And then I'm going to add plus memory recall equals. This is where I want to be. All right, that is where I want to be. I'll try that again, make sure I did it right. Clear it all out. So remember, we're moving half the diameter of the end mill. Equals that. And then, okay, divided by 2. All right, there we go. That equals that. So you just have to add that to this number each time. So if I put in 10.8 and I go plus memory recall equals that, that is what this number should be. So we just go copy. Now watch what happens. Paste. Cool. Control S if you haven't done that. And here's the other cool thing about it. Paste. Huh. You're going, what? That's all there is to it? Control S. Yep. Now I just cut another circle. Now remember, this is going to be the radius of the pocket. This pocket's 100 millimeters in diameter. So we're going to keep doing this until we get up to 50 millimeters, until this number hits 50 and this number hits 50. Now, how are we going to, we're going to do some other stuff up here. Remember, what size should I tell? Remember, because we're going to leave, we're going to tell it, we're going to lie to the control. We're going to tell it that we're using a bigger end mill than we actually are, like 30 thousandths bigger, so it gives 15 per side. So I have to do some stuff here. So let's clear this out. 0.03 plus 0.75. Okay, so it's 780 thousandths. You can't put 780 thousandths in the control because it also wants you to express the diameter of the end mill in fractions, so, or in millimeters, excuse me, times 25.4. So I'm going to put something right here. Okay, I believe that was 19.812. I was at 19.81. Okay, no, 19.81 in control. That is the, don't forget that. Okay, 19.81. That is the diameter right there that we would tell for D1. That's, we'd tell it to use that. That would give us our stock. All right, Control S. All right, well, once we put that 19.81 in there, we get our G3. Guess what? We just have to keep doing what I just been doing here until, so we get up to 50. All right, so N120. So I'm going to go G1. And now what do I do? Well, here's the cool thing. I just go in here. Now, that's the last number Okay, let's do this. The last number I used was the 20.3. We'll get going here. 20.325. Okay, now I want to move up from that half the diameter of the end mill, which I got that. So it's plus memory recall, all right, because that's half the diameter, equals that. Copy, and we'll get going here. Oh, that's a GI, isn't it? There we go. And this is going to be a Y, and I'm going to paste 29 point. There we go. So that's our next cut. In 130, G3, now, and J minus, and then I just paste again, and I hit Control S. New line. In 140, G1. Now we have to figure that up. Now watch what happens here. See, we've already got that number right here. So this time, here's where it gets automatic for you. I just have to add what's in memory, right? Plus memory recall equals, there's my next one. So I got a GI again. What is going on with me in the eyes today? All right, so Y is going to be, and I already copied it, paste. No, I did not copy it. Delete. Yeah, I want to copy this. Copy. Paste. Okay. New line. And here we go. So what we're going to do at G3 again. J minus and paste. Okay, like I said, we're going to keep going until we get to 50. New line. Control S. G1. Now I should bring this up and it should be already got that. That was our last move, so I just go plus memory recall equals, then I go copy, I go up here, space, Y, paste. New line. See, you can see a pattern starting to develop. And see, paste. Remember, paste anytime you can. Control S. Now what do I need? I need my Y, so I'm going to put my Y there. Go over to my calculator, click calculator up, and at this point just go plus memory recall equals, there we go, copy and paste. Now let's look at that. That would have scrapped the part out. If I move that to 50, right there, 58, remember the radius of this diameter, remember radius is half the diameter is 50, so let's scrap that out. I can't do that. I can't move it. That was at 48.9, so almost 43. So we're talking about 3 millimeters there for the next cut. Plus, also I'm leaving stock. So you know what? That's not going to be a problem at all. We could just go right to 50. Yep. Control S if you haven't done it. In 190, G3. So what I wanted that to be? Well, that should be a J minus 50, shouldn't it? Not 5, 50. Control S. At that point, folks, what we've done right here, right now, from N60 to N190, we took all of these, we made what? Let's see, 1, 2, 3, 4, 5, 6 circles. We made 6 circles, 6 complete circles, each time moving out further towards the outside till we got to 50, which is our radius. And at that particular point, that pocket is done. Now remember, we did tell it that it had a bigger end mill than actually was in there. Okay, so we would have left 15,000 stock. We left 15 thousandths here in Z, and we left 15 thousandths, okay, in X and Y. So the pocket is not finished. The pocket isn't deep enough. The pocket isn't to size. So what are we going to do? Well, you know what we're going to do. We're just going to go ahead and copy and paste all the way from here. We'll resequence later. Go copy. Bring this back over here. Put it right here. And if you want to put a space, not a space, but a line. There we go. Let me just put some lines here to get this. All right. Click there. paste. All right. Now, you're going, Randall, didn't we do any... something's not right. Yes, something's not right. What's not right? I didn't cancel my cutter comp. Remember, the rules of cutter comp say that you can't make any Z moves between the G40 and the G41 and the G40. I don't have a G40. I will here in a minute. We're going to resequence these using, so here we go. So G01, excuse me, G1, G40, and I am just going to, just to make it nice and neat, I'm going to move Y back to 0. Now you normally wouldn't have to. I'm actually, since I'm not cutting anything at that particular point, I'm just turning the cutter comp off, move back to 0. I can bump that feed rate up. Let's say 400 millimeters per minute. So there, I turned it off. All right. Now, what's another thing we probably had to put in there? N210. All right. Since it's a good idea, now this is something that there'll be some people will disagree with this, but I always do it. Especially if this was a very hard material, it was a very deep pocket, I may have a lot of chips build up in it, and there's just times when it's, especially you want chips out of the way. Chips will actually cause the end mill to deflect. They will. It'll give you a bad surface finish. They're bad things. Now, if you got a heavy coolant pump like 50 gallons per minute or an air blast or something like that, it's not going to make a difference. But in this case, I'm going to go ahead and give that a G28. That's right. Okay. Z. Now, what was, as I believe 4 inches is 101 something. I'm going to have to calculate that up. So 4 times 25.4 equals, we got 101.6. All right, so Z 101.64 inches. That'll make it a good clamp jump. And now, since a lot of people would not do that, I'm going to put in here only if hard M-A-T-E-R-I-A material, only if hard material, or let's say lots of stock, or Control S. I'm just going to put that little note there. You don't have to use that G28 every time. There's lots of different ways, but for right now, just do it. We'll just do it. That'll give us a chance to clear out the chips. It'll go home. And why I say hard material, because remember, if I'm bouncing around in here and I'm taking big heavy cuts and things like that, the machine's going to build up what's known as following error. Now, following error makes it a little less accurate. We won't get good part geometry. So sending it back home with the G28 will recalibrate all the axes, refresh everything, and then you can come back and take your finish pass with no worries about there being any buildup with a following error. If you're running an older machine, okay, this is a very important move for you to make before you do any finish pass. Seriously, older would be, well, you decide, if it's 20 years old, it's old. Okay, it'll have enough movement in there. I ran one once, you could actually watch the whole thing wiggle as it was cutting. So we always had to send it back home for a finish pass. So that is something. There you go. Hard material, lots of stock, machine age. I can't put all the variables that are in there. All right, so I copied this back up. All of these numbers are good except for this Z. Now this time we want to make Z, well, we're going to finish that off. So 10, don't forget your decimal point. Control S if you haven't done that. Everything else should be fine. All of these moves are going to be half the end mill. We are going to change this to D02 because that this time. And what am I going to put in the control? 19.05. Control S. So what that's going to do is I'm telling it it's got the real size. So this right here should make a nice finish pass. And that's all I have to do. Now, I can copy these 2 lines right here. I don't even need all that. I'll just copy this. Go back down here. Remember, we're going to resequence, paste, Control S. Okay? So we went to G3, that made that finish pass. Remember, there's no stock here. At this point, we've eliminated the stock in Z. We've eliminated because we're using the on size till it's an on size end mill. So the right size end mill, 3/4 of an inch, and we moved it back in there. That right there, folks, for all practical purposes, is enough to make this whole thing work. Seriously, I'm hitting Control S just in case I haven't done that. I'm going to resequence it. So what else am I going to do? Well, M30, try not to sequence that. I swear to God, it won't matter most of the time, but there are some controls that will just freak out about the M30. Okay, remember I got my G28 right here, so it's going to go home. I only used one tool. We didn't do any multiple tool changes or anything like that. M30, and then of course, now this is very important. You do not put anything on that line except the percentage sign. Control S. That right there, what we did was we took 2 passes and we milled out this pocket. 1 pass leaving 15,000 stock in Z and 15,000 stock by telling it we were using a larger end mill than we actually were, so it stayed further away on all sides. And then we went back in here. Okay, we changed their D number, we changed their Z number. That's all you have to do. Isn't it beautiful? And in the control, we'll tell it that D number 2 or tool number 2, the diameter is actually 19.05, and it'll take care of the stock in X and Y. Now, everybody look at that and they go, oh my God, really? Now, I'm going to tell you another little history lesson. There used to be, and there still is on some controls, a G code known as a G13. Okay? There's G12 and G13s. What that does, that was a canned cycle, and it did this circular pocket without half of this stuff in here. You're going, well, why don't we use that? Or will we use that in the future? There's a problem. Fanuc, and it's in their infinite wisdom, the software engineers at the Fanuc control people, anyway, they decided that the G12 and G13s weren't something they wanted to deal with anymore, and I don't know why, so they do not support those codes, which Fanuc owns like an awful lot. Now, Haas's will support a G12, and later on I might show you how to do that, but this is sort of a beginning class, so we don't have to get too fancy with that. This right here will do everything we need it to do. Now, again, if it's a deeper pocket, you're going to take multiple Z passes. Okay, I could program in a multiple Z pass so easy it's unbelievable. I mean, I could change this right now. Let me just show you. Let's say, okay, so I want to make that 5. I'm not going to hit Control S because I don't. This one would be, oh gosh, what was that number? Dang it. Let's do this. This is cool. Undo. It's 9.61. Why don't I copy that? Yeah, because I'm going to change this back. I go 5. Go down here. Paste that right there. Paste. Now remember, this is, don't use that extra decimal point. Ain't worth a dang. I did hit Control S. Out of habit. And now I've taken 1 pass at 5. Then 1 pass, and guess what? If I want a 3rd pass, I just copy again. I'm just going to copy right to there. Copy. Go down here, open up a line by hitting enter, and I'm going to paste. So much for my line that got opened up there. Right, here's where I wanted an open line. Enter. And guess what? Now I just changed this to 10, not 100. That's too deep. 10. Okay? And you know what? I'm going to go back up here. This is D0. I'm going to change that back to D01. So I got 1 pass that's at 5 millimeters deep, leaving 15,000 stock. Okay? In X and Y. I got a 2nd pass that is leaving 15,000 stock in Z, and still 15,000 stock in X and Y. And I have a 3rd pass right here. Okay. By the way, this one's going to be the, if I'm going to do this right. What was that? 19 point, I have to look and see what it was. 19.81. I'm going to hit Control S. you know what, this is good. It doesn't hurt for us to do this. It's good practice for you. So this is probably the way I'd like. Go ahead and do it like this. Okay, you got your DO1 there. I'll go back over it again. And minus 10 with the on-size end mill, DO2. Okay, there you go. Now I've took 3 passes. Look how easy it is. Once you get this down, okay, once you get this down, all you have to do is just copy and paste and change a few things, and you can make multiple passes, which, remember, that's a good thing. So 5 millimeters is probably, this is more realistic, most likely. Some people would say, oh, your step over percentage shouldn't be, but 5 millimeters deep, and I'm taking a 3/8 thick pass on each circle. Oh yeah, that'll be fine. What is 5 millimeters? Well, let's figure it out. All right, 5 times 25.4, 100. What? Clear that. That is not right. Let me try every now and then. 5 times 25.4, 127 millimeters. Okay. No, okay, I see what I did. 5 divided by 25.4, duh. 196 thousandths deep. Yeah, that won't be no problem at all. So this is a more realistic program right here. We're taking 3 passes. Take 1 pass, leaving 5 millimeters deep in Z. Second pass, leaving 15 thousandths. Converted. Everything has to be converted. Everything has to be converted. We're still using D01, and we're leaving 15,000 X and Y, 15 thousandths in Z, and then a final pass where Z is actually to depth, and we're using the right size end mill, so that would make that. And that would work real well. Now, let me see here. I had F400. This F400 right here, that's good. F400 up there, that's good. F400 right there, because this move, remember, this move right here, we're not cutting anything. Now, actually, you know what? Since this is the very last pass, 400 inches per minute would probably scar that up. So I'm going to go back to the 63.5. It would leave a bad surface finish. It would go like this and leave a bad surface finish, because that's my final depth. So on this move, I'll just leave that at, actually, I could just do this. Why don't we just do that here? Control S. There we go. These two we don't care because we're leaving stock in Z, but that one right there we don't want to. That cutter is still rotating, and we're turning the cup. Now you could turn the cutter comp off. We could have rapided straight up from that point, but it's best just you're learning, so just go ahead and do it like this. This works. This will work real good. All right, so let's resequence this puppy dog. Control S, Control A to select all. Remember. Let me show you how to do that again. Just put your insertion point any place. Doesn't matter. Hit, hold, push Control A. It selects everything. Then put the insertion point someplace in the blue and right-click. Excuse me. Yes, right-click and go down to Copy. All right, so we're going to get Predator Editor going here. Boom. Dun, dun, dun. Hopefully you downloaded this. Especially you guys are actually doing this for real world. This is a nice little thing to have. Okay, paste. Now, process, resequence, I'm fine, apply to, boom, hit Control A again. Now look at this, there's a bunch of stuff there, there's a bunch of ghost code, see it? Delete it, get rid of that ghost code, because that will cause errors. So I'm going to go Control A, and then I'm going to copy, I'll just cut, heck, I don't care. Close this, no, don't save it. And then I'm going to go back here, and I'm going to paste that back in there. Now all my numbers are nice and sequenced. Control S. See how easy that is? Some of you are not resequencing your numbers. I'm going to start, like I said, if your numbers aren't sequenced properly, I'm going to start counting them off. We're getting ready. We're getting close to midterm, so we'll talk more about that later. But so this is 5 right there. So we did that pass. Let's see what this looks like in NC Viewer. Okay. Now, I don't know how powerful NC Viewer is. I know Chemotics wants me to put an F code, a feed at every one of these dang G codes. I ain't going to do it. I wanted to show you Chemotics because it is pretty cool and it does 3D. Here, I'm going to show you. We'll just turn it on real quick. Wow, isn't that neat? Yeah. Problem is, it works best with this TPL language, which that means toolpath language. That is not a language we're teaching. You can download this for free. I put links into it, but trust me, it's got a lot of bugs in it. It certainly looks impressive. You can change your views. Here's your simulation. It'll actually show you the cutter. You have to put the cutter in the tool table here to do it. It does stock automatically or manually, but it does not do cutter comp. If it did, I'd try to make it work, but it doesn't. So it still does everything as running the center line of it. So I just wanted to show you that. I'm going to turn that off there. We're not going to use that. We're going to go ahead and get NC Viewer. NC Viewer here. There. Oh, come on, Randall. Boy. There we go. Cannot type today. And Eddie Van Halen thing's got me pretty freaked out, believe it or not. I know that sounds like a wimpy thing, but I was a big Eddie Van Halen fan. Smoked himself to death, people, just like my father. Quit smoking cigarettes. There, that's my public service message. So I'm going to paste that file right in there. Boom. Okay? Now, if you haven't noticed something, this is something I notice about. I'm going to leave that right there, but something I noticed on this. We should take 3 passes. So let's see what we all got there. We got everything going. We got it nice and resequenced. Beautiful little program. Didn't take that much to do. If I hit plot, it's going to run it. I'm going to get this out of the way. You can do that. And I'm going to actually zoom out just a little bit. This should make us a 100mm pocket. No holes or anything. We're going to do that on the next one. Now, if I hit that right there, I think you have to turn the plot button on. This is no plot. This is plot. Why would you never not want a plot? I have no idea. But anyway, these things are all a little different. Let me see if I'm right about this. Okay, nope. You have to hit plot. Boom. There's my plot. All right. Now, I'm going to zoom out a little more and center this a little bit so you can see it. And then we're going to zoom in. So let's go ahead and rewind the whole thing back to the beginning. Gosh, I really hate that. I don't know why it wants to do that. That seems so stupid. Am I going to single block this all the way through? God, no. I will for a little bit. So, here we go. Watch the digital readout. See, now I'm at, it says it's at 2.54, which is 100 thousandths, right? There it's going to, now see, it's not going to cut. It's just showing you the endpoints, but it is showing you that it would do it. So do a circle, then the next one, move up, do a circle, next one, move up, do a circle, next one, move up, do a circle. Then it should feed back, right? Then that's at G28. Okay, you can look over here and see that. And you should do this because now we're coming to we're going to do our second depth. Now this one, that last one should have happened at Z.5. I'm awful positive it did. I did not double check it. This one is definitely leaving stock like we want it. Remember, we are telling it the control, we're lying to the control, telling it that the end mill is bigger than it actually is, so it's staying further away, leaving stock. So here we go, and we know it's going to work. We know it's going to work. So you can see that nice little pass. We're looking at top view here. And then finally, let's just do the last thing here. Now we're at Z minus. See, that says Z minus 1. It sure does. Here's my Z minus 10. So guess what? NC Viewer has got some bugs in it. What a surprise. If it's free, what do you expect for free? What do you want for nothing, right? A rubber biscuit. All right. Those of you who may get that pop culture reference. If we take a look at the top view, okay, you can see there, here, let's bring this down a bit. Here, we'll zoom it back out. You can see that our last pass there. Now, since it doesn't do cutter comp, we can't see the very last pass. In other words, since it doesn't do cutter comp, and by the way, this is just the graphics. This will be in a real machine. There'll be no flats here. That'll be very, very smooth. Okay. As the further out I get, the more round it appears. All right. Now let's go back into the home and take a look. I want to see about my Z cuts. That's what I want to see. Now we can zoom in. See, here's our first one at 5. Here's our second one at, what was it, minus 9.6 something. And there's our final Z path right there. Here, I'll get that even closer so you can see. And I can rewind it. And then if we run it real quick, It's hard to see it. That's it, though. It did work. All right. Wish there was a way to. This goes full screen. That doesn't work good. Zoom back out. Come on back down here, you. All right. And that's as easy as it gets. I mean, seriously, that is probably one of the most. You do that and show people, and you come out with a circular pocket. And by the way, this whole copying and pasting thing works for rectangular pockets too, or any weird, any geometry pockets you've got, as long as you move to the inside. Now later on we'll do some more of those. When you get to really fancy geometrical pockets with a lot of arcs and curves and tangent points and things like that, manual programming is not probably the way to do that. But there you go. Okay, so the next one, like I said, we're going to drill holes in here. We're going to use the same program and we're going to put holes in here. We'll see how that comes out. It may end up being so busy looking that I can't. Yeah, so you can turn this off. But if you run it, here, rewind. I got it rewound. See, it doesn't do anything. Now I turn the plot on. See, you've got the little square around it. That says it's off. And honest to gosh, this is so, I don't know what this does. You fool around with it if you want to. I don't care what that thing does. Turn that thing off. Turn the plot back on. Okay. All right. Thanks for watching, and I'll show you how to drill the holes next.